Yes, hold on to it. What? Julie, you done? Yeah. Turn your paper over.
Next bathroom.
Mm-hmm. Okay, 2 minutes left. 2 minutes left. Yeah.
We just keep it like this afterwards.
Yeah, I'm about to collect it right now. All right, make sure your names are on them. Pass them to the left. Pass them to the left.
I got it. No, you don't know your lesson. No, I was speaking for you. Yeah. Yeah.
What?
I remember like the same thing. But like,
This is the same operation.
It was like something like that.
That's a good
All right, I'll collect your homework at the end of class. All right. Hey, today's crazy.
We had homework? Can we do that? We're gonna do this.
Agreed. That's your homework. This right here, that was your homework. What? You did. All right, so today's, if we think about the important lessons of the year, today's like where rubber really hits the road. We're going to do a couple days of this. We'll do one day today. Tomorrow, even though it's a different section, it's really the same material. And then we'll have a practice day on Friday. Right? We cannot walk out of this classroom without you understanding what's going on. I'm not going to claim today is crazy and complicated, impossible to understand. It's not. But it's brand new. You've never done this before. Some of you will catch on like that. And you're like, why is he making such a big, because you're going to use this for the rest of your high school career. If you take math in college, you're going to use what we're about to teach you, right? Whenever you factor a quadratic, this is what you're going to do. Okay? You're going to factor lots of quadratics, which is why I got 3 days. If we get to Friday, the practice day, and you are completely, totally lost, I'm going to claim you're not doing your job as a student, right? If you sit there, you pay no attention, you can absolutely get to Friday and not know what you're doing. So for those of you that sometimes I don't think I have your full attention, Sarah, you'd be one of them. I need you to really pay attention today. That means you're looking at the board or you're doing your work. Okay? We can't get to Friday and you not know what you're doing. Friday is just simply designed for I can individually help some individuals. But we get to Friday, you're like, I don't know what I'm doing. You're not doing your job as a student. You should know what you're doing, but you might need some help of getting the confidence to do it. This skill I'm about to teach you is also highly dependent upon basic math facts. Can you tell me all the factors of 16? 1, 2, 4, 8, 16, right? It's highly dependent upon that. We have a couple people in this class, though they're a little weak on that. So your ability to do this skill is dependent upon your ability to look at a number and tell me the factors. If that's what you're weak on, okay, we can work on that. But we can't work on, I don't know what the procedure is, what to do. Here we go. Here we don't go. And put it on off freeze. All right. I love this class. I mean, this material right here. This is fun stuff. I don't know why it's fun, but for me, it's fun. All right, homework 1 through 18 all. If you get the idea, this is quick work. Like, I don't know, 10 minutes worth of homework. If you're weak on factoring, right, finding the factors of numbers, this is a 30 to 45-minute homework assignment.
That's annoying.
Right? If you're weak on your basic math facts. For those that are strong, this is quickly done. Okay? Most of you are strong in this class. Right? For the weak people, I don't want you to do more than 45 minutes worth of work on this. Like, you're not going to make any progress if you spend 2 hours on this. You'll get the same amount of effort and benefit out of doing 45 minutes as you would out of doing 10 minutes if you know what you're doing. I'm going to teach you some magic today. It's magic. It's absolutely bloody magic, right? No kid figures this out by themselves, right? It's not intuitive. It's not something, oh, I already know the answer just by looking at it before you talk. It's not. But the procedure is pretty simple. Here we go. This is weird. This is what it says, right? It's Algebra 1, right? The days of nice, easy math are over with. So it says factoring. We just did some factoring on the quiz. Factoring something that looks like x squared plus bx plus c, where c is a positive number. That means this number right here is, tomorrow we'll see where c is a negative number. But for today, c is going to be a positive number. Don't get too hung up on the title, right? If I were writing this book, I wouldn't have given it that title. Here we go. Huge, huge, huge important lesson. All right. You already know, because you literally just took the quiz, to take this and to turn it into, you may do that in their head real quick.
X squared plus 5x.
Okay, so x squared plus 5x plus 6, right? You already know how to do that. I mean, everyone in this class knows how to do that, right? You also know how to do it with a special case one. This one turns into, okay? This one's a little bit harder to remember the rule for special case. All right, with the exception of one person, and it's hard for the rest of us, right? But that, by the way, that's what the quiz was. Just how a third of the quiz was on this stuff right here. Okay. Today we're going to go in the opposite direction. I just gave you the quiz going in that direction. Today, right? Oh, by the way, we either use the short method, the vertical method, or the special case method. Today we're going to go in the opposite direction. I'm going to give you what's in yellow, Sarah. I'm going to give you what's in yellow. You're going to turn it into one of these.
Haven't we done that before?
We have not. Not for this. We have factored, you just had it on the quiz, we factored a binomial. Now we're going to factor a trinomial or a special case one.
This is a polynomial.
Okay. Yeah, and it's basically factoring polynomials. So right now, you can factor this. We had a class on the special case one. You've probably already forgotten it, and that's fine because I'm going to show you a different way of doing it. So if you forget how to factor a special case one, right? If you forget that that's a special case, it factors into this. I'm going to teach you another method, and it's the #1 method that everyone remembers. Most people forget, like, oh, that's right, that's a special case one. Everyone remembers this class right here, okay? Because like I said, some kids will look at this and they won't even recognize it as a special case one. All right, so this is called the factored form, right? This is called the simplified form. The big but here is that some of them aren't special case. The question is, how do you factor this, right? Special case one's pretty easy. You take the square root of this, you take the square root of that, and you write that like that. You take the square root of the first, you take the square root of the second, you put plus, it's easy. If you recognize the special case. But some trinomials are not special case like this one. Our job today is to factor this, to turn it into a binomial times a binomial. All right. By the way, this only works is if I give you one that's factorable. Some of these exist that are not factorable. We won't see that until, I don't know if it's tomorrow or the next day they bring that in. But occasionally we'll get to unfactorable trinomials. Okay? We simply put unfactorable, and that's the answer. Yeah. And then some of them will have prime numbers. All right. So our goal is to turn that into that. Well, how are we going to do that? Well, I'm going to claim it's called factoring, right? We just had a quiz on this, right? We factored a binomial, right? What common thing here is a 2 and an x. We factor out a 2x. So we already know how to do that one. We don't know how to do this. That's the goal today, tomorrow, and Friday's class. So here we go. We'll go slow. I don't know if challenging is the right word, but it's certainly new. You've never done this before. All right. We talk about trinomials in general being of the form, there's a number attached to x squared, there's a number attached to x, and there's a constant. That's why you have an a times x squared plus a b times x squared plus c. Don't get hung up on a, b, and c. They just represent numbers. You're always going to have an x squared. Occasionally, you're going to have, well, I should say most of the time, you're going to have a middle term, and it's going to be attached to x. Okay? All right. An example of that would look like this. Right? Oh, by the way, there's no number here, or is there? There's a 1 there. So this is the case of where a equals 1. Today we'll be doing only trinomials where the a value is a positive 1. Okay, here's another example. Here's another example. Either these will both be pluses, or they'll both be minuses, or there'll be a combination of plus or minus. But notice, in each case, the a value is 1. Today's magic only works when a equals 1. This magic I'm about to teach you only applies when there's no number attached to x squared. Everybody with me so far? Okay, cool. By the way, there's plenty of other trinomials where a does not equal 1. This is a 3-day class. This is a special class. We'll do it next week. And this is when the a value is not 1. Typically what happens if the kids stay with me and they get this solidly, we get to this, and this is no big deal. We might do 3 days of it, but it's no big deal. If I can lose you on this, we don't have a chance on this.
Wait, I thought,
So,
sorry.
go ahead.
I thought factoring was turning it into parentheses.
We do, and you will be.
What's that?
Well, no, this is what it looks like to start with. This is the start of the problem. This is not the factor form. I'm going to give you, tonight for homework, it's going to look like this. We're going to give you this one, and that one. By the way, today's class is where things are, C is positive. Okay. All right, so this is the ones where a does not equal 1. That's next week. Okay, so if you think about this, there's 3 different types here. One where both are positive, both negative, or a mixture of positive and negative. And there's a 4th one where their a is not equal to 1. So I got to teach you 4 different things. I'll teach you 2 of them today. All right. So what do we know? Well, we know we can go in that direction, and our goal is to go in the opposite. I'm going to give you this. You're going to turn it into that right there. So some magic has to happen in between. That's what I'm going to teach you today. All right. There's 3 cases when a doesn't equal 1. One where the answer, both things are positive, both things are negative, or there's a mixture of a negative and a positive. Now, both of these I'm going to combine into one case. So there's 3 ways that this can happen, right? When a equals 1, the rest of the stuff is whatever it is. There's 3 possible answers. So we'll cover each one. Today I'm going to cover the first 2. Tomorrow we'll do this one. Okay? All right, so don't panic. It's not as bad as I'm making it sound like. This into this. Here comes the magic. All right. So a equals 1, right? It looks like this. Both things are positive. This is what you do. You ready? It ain't that big of a deal. It's not that much magic. Here we go. The book would love you to do a table. Nobody does a table. The book would love you to make a table. In fact, when you look at the example of the book, they're going to show you a table. Do I expect you to do a table?
No.
I'm going to show you the table.
What?
Some of you might like it. Others of you will do the table in their head.
It's so cold. Baby.
All right. What did I tell you what happened in 5 minutes? Blame, who was it? Who did I say we would blame? One of you said, it's so hot here. And I said, okay, I'll turn down to 70. You'll be cold in 5 minutes. All right, back to here.
I can see my air.
Look, you can see your breath is what you want to say.
I can see my hair.
All right.
It makes sense.
The book would love you to make a table. Here's the table. It's got 2 columns. The first column says factor pairs of C, and the second column says add them up. That's what sum means. So here's what we do. We find C. Where's C up here?
Plus 6.
Give me every 2 things that you can multiply to get to 6.
2, 3, 1. 1 times 6.
Is there anything other than 1 and 6 and 2 and 3?
6.
By the way, 6 is positive, so that's what we write. 1 and 6, 2 and 3. Second column says add them up. What's 1 plus 6?
7.
What's 2 plus 3?
5.
See what I did? The book would love for you to make this. Most people do this in their head. Okay, here comes the magic. one of these columns, one of these numbers matches that number right there.
Oh, it's 5.
So one of these numbers, the second column, will always, if this is factorable, tonight they'll be factorable, one of these will always match the middle one. You just got to find that. I'm looking for a 5. There it is. Here's the magic. The answer to this is 2 and 3.
2.
The answer to those question marks appears wherever this 5 is. Whatever number appears here goes here. Whatever number appears there goes there. And it doesn't matter if you mix them up. If you want to put 3 first and then 2, it's the same answer. Because remember, multiplication is commutative. So my claim is that if I put a 2 and a 3 for these question marks, that this turns into this. Let's see. What's x times x? What's 2 times 3? What's 2 times x?
Holy crap, this is easy.
What's x times 3? What's 2x and 3x? It works every time. If it's factorable. Some won't be factorable. Let's see that again. Different one. Give me the factor pairs of 12.
6,
1 and 2. 1 and 12.
6, and
2 and 6. And 4 and 3. I'm going to claim that one of these adds up to 7.
3,
Well, like I said, the book would love for you to make this table, but most of you, like myself, would say that's silly. I already know which one adds up to 7. Which one adds up to 7?
3,
So guess what these question marks actually are?
3.
There's your answer.
Okay, wait.
Wow.
So let's see. 3x times 4x is, there's 3 times x is, x times 4 is, and together they add up to 7x, and 3 times 4 is 12. Boom, you're done. I didn't say it was hard. I just said it's new. Some of you are going to need to see 20 of these, and that's fine because we're going to get 20 of these. Others of you need to see about 4 of these, and you're like, I got it. Get started on your homework. Okay? Here we go, box 1. Box 1. I'm always looking for the factor pairs of the C value, in this case 16.
2 and 4.
So I would always start with 1, and you can't skip 1 because usually what happens is a kid will say, it's not factorable, and I'll say, you forgot. And if you forgot, it's typically because you don't go in order. So let's see, 1 and 16, what else?
2 and 4.
2 and 8,
4, and 4.
and 4 and 4. Yes? One of these adds up to 10. Which one? So therefore, the answer is 2 and 8. Okay? If you want to put it in the table, then you're adding, you're identifying this 10. Oh, it's 2 and 8. So there's your answer. If you need convincing, x times x is x squared. 2 times 8 is 16. This gives me a 2x. This gives me an 8x. 2x plus 8x is 10x. Okay, factoring ain't that bad. Oh, by the way, it's something new you didn't know 20 minutes ago. The bigger question is, why would I ever do this? That's what algebra teachers do a very poor job of telling you what this is for. And I'll tell you why, because it's a complicated answer that you don't get to see for a couple chapters. Trust me when I say, when you see why we do this, you'll understand why we put such great importance on this. Okay, now box number 2, here we go. Factor pairs of 20.
5.
Start with 1. 1 and 20. 2 and 5 and 4. Smarty pants kids probably say there's an easier way of doing this. Okay, smarty pants kid, tell me what's the easier way.
What?
Anybody?
I think this is the easier.
I said do them in order, and I usually have some smarty pants kids that says, no, I want to do it this way. Anybody? And I'll tell you the method, by the way. Instead of listing them all, why don't you start with 9?
Yeah.
9 is what I'm looking for. So do I need to consider 1 and 20? Do I need to consider 2 and 10? I need to consider the factors that add up to 9. That's only 4 and 5. So what Tristan immediately said was 4 and 5 was the right answer. Okay? However, I got some kids out there that they can't think 3 moves ahead. You got to think 3 moves ahead here. So for everyone else, start with 1, then 2, then 3, so forth and so on, and then see what 12. For me, if I'm going to do scratch work off to the side, watch me. Instead of doing that table, this is what I do. 1, 10, 2, 1, sorry, 1, 20, 2, 10, 4, 5. That's all I need to write down. I can see which one adds up to 9 immediately. See what I did? I'm kind of doing the table, but I'm kind of not. Does that make sense?
So then you do the numbers in order.
Yeah, the reason why you want to do the numbers in order is because tonight they're going to give you potentially some ugly numbers, and if you don't do them in order, you might forget one, and that'll be the answer. I forget this book class. It's typically second day or it's the third day when we do this. There's one that I always have to point out to kids and like, oh, that's right. I didn't even think about that one. Oh, by the way, what's the answer here? What's the answer here? Well, yeah, but how do we write the answer? X plus 4, X plus 5. It's not that bad. Okay? Yes?
When you have a minus on one side, do you minus
We're going to talk about that next. We're going to do all pluses first, and then we'll do minuses. Okay? All right, you got 4 of them. Do you want me to do them with you, or you want to try them by yourself? Rowan's going to speak for the class? Okay, do them by yourself.
So did I get this one right? So you do.
Yeah, and so X plus 1, X plus 8.
Why would we do that? How do we get to X?
Yeah, let's get 2 more parentheses.
How do we get to X?
Well, that's it. This is the answer. That is this factor.
We're just adding X.
Yeah.
Oh, okay, cool.
And it's going to be done the same way each time until we get to next week. Next week is when we get where A is not 1, then it's done slightly different. All right, see, the first one, I got to get to 15. But I'm thinking about 8. Well, the only 2 that get up to 8 would be 3 and 5. 3 times 5 is 15. 3 plus 5 is 8. So it's X plus 3, X plus 5. This is why I'm going to say that this is generally done in your head. It's not done with scratch work. Right? You're kind of expected to be able to do this in your head, but it's okay if you can't. Right? Julie, give me 20 that adds up to 12. Okay, Julie's got this. I can stop right now. I don't mean it like that, but kind of did. Right? Julie's got it. You guys should as well too. It's not that big of a deal. X plus 2, X plus 10. Also, it doesn't matter how you write it. If you want to put X plus 2, X plus 10, it's the same answer. I already showed you the answer. 8. Tristan already saw on his paper, he put X plus 1, X plus 8. Okay, 1 plus 8 is 9. 1 times 8 is 8. Nathan, give me 30. That adds up to 13. Start with 1. 1 times what is 30? Does 1 plus 30 add up to 13?
No.
Nope.
Okay.
What's the next one? 2 times what is 30? Okay, remember the first statement that I made. I said that the process isn't that bad, but your math facts, your ability to look at a number and tell me the factors, that's where we usually wind up a problem. For those kids, if that's your issue, I'm going to tell you, absolutely 100%. Start with 1, then do 2, then do 3, then do 4, 5. Don't skip a number. Obviously, 4 doesn't go into 30, but I'm saying consider 4. You will have plenty of time to do a test. The fact that some kids could do this in their head and other kids need to write down the factor pairs is fine, as long as you know the procedure. Nathan, do you know the procedure though? So let's write the factor pairs of 30. You said 1 and 30. 2 and 15, 3 and 3 times what is 30? I'm going to suggest a multiplication table. And 5 times
6.
one of these adds up to 13. Which one?
5 and 6.
5 and 6 adds up to 11, not 13.
Oh, 3 and 10.
3 and 10. Therefore, the answer, Nathan, is. Yeah, but how do I write the answer? Let him talk.
X plus 3. X plus 10.
You know the procedure. Your issue is this part, yeah? I'm just going to say, have a multiplication table in front of your face. It could speed things up. Anyone else? I'm lost. I don't see what's going on. Where are you getting these numbers from? This is the hard part, by the way. There'll be a couple ugly ones tonight for homework, but they're not too bad. Okay. True? Okay. Why does this work for those of you that care, right? Some of you are like, I don't care as long as it works. The reason why it works is because of how we get from here to the trinomial. Remember, we know an x times x, that's your x squared, but the two middle terms, that's the 4 times x, and the two outer terms, that's the 5 times x, are what add up to that middle term, right? These two added together get us to the middle term. And by the way, 5 times 4 is how we get to this 20. So why does it work? Well, it works because of the way the multiplication, the distributive property works. That the middle term is the sum of these two pieces. And by the way, these two pieces are what multiplied together get you to that 20. That's why it works. Okay? Most people are like, I don't care, as long as it works, it works. Okay, so we just did which case? Which one did we just do?
X plus here, X plus
We did when everything was positive, right? So check that one's done. I said we're only doing 2 today, so we'll do this one now. This is what
Sierra.
Hannah's question was on. I don't know why I couldn't think of her name there for a second. Okay, so notice, hey, we got a negative, we got a positive, negative, positive, negative, positive. Okay?
Wait, but what if they're
Well, that's tomorrow's class, right? We're going to cover all of these cases right here between today and tomorrow. Yeah.
what if the C and the AX squared is flipped?
Then you're going to move the C to its proper position. All right. So here we go. Notice you can get a positive 8 2 ways. What are the 2 ways to get to a positive 8? Give me factor pairs of 8. 2 and 4, and actually there's not 2, there's 4 ways to get to a positive 8. What's the other way of getting to a positive 8? You said 2 and 4 and 1 and 8, and I said there's 2 more ways. How about if it was negative 2 times negative 4 and negative 1 times negative 8? So it turns out to get the last term positive, there's 2 ways. Either both factor pairs are positive or both factor pairs are negative. Okay, how do you know which one you want to use? Right there. Notice on the previous one was the B term positive or negative. On the previous ones that we did, was the B term positive or negative? Somebody.
Positive.
Right. So we only needed to think about positive products. But this time our B term is, so therefore we need to consider the negative ones. A negative times a negative is a positive, but a negative plus a negative is a negative. So this is just being on the ball. The process doesn't change. What changes are the signs. Okay? So this one, when it looks like this, the answer will actually look like this. You better do so. Okay? All right. Hey, C is positive, but B is negative. So now when we consider 8, we got to consider, well, we got to consider all the possibilities. Either both terms are positive or both are negative. Most people are doing this in their head. Of these, which one adds up to negative 6? Which one adds up to negative 6?
Negative 4.
You see it? Negative 1 plus negative 8 is negative 9. 1 plus 8 is 9. 2 plus 4 is 6. But negative 2 plus negative 4 adds up to negative 6. So the one that we need to consider when the C term is positive, but the B term is negative, are, well, it's going to be one of these two are going to be your answers. So technically, if you recognize this pattern, you don't need to consider that. This is going to get complicated. And the reason why I'm showing you all 4 is because the rules are hard to remember. It would be easier just to think about all the possibilities of getting to a positive that add up to either positive or negative. You'll see why in tomorrow's class. Okay? Oh, by the way, what's the answer?
Negative 2.
Yeah, but this is the answer. Read it.
X minus 2 and X minus 4.
So the process doesn't change, but the values that we consider changes. I don't need to consider the positive one because B is negative, right? There's no way to add up 2 positive numbers and make the answer negative. The only way you get that is when the 2 things that you're adding up are negative. So now I only need to consider this. How are you going to know to do that? Well, you got to be on the ball and pay attention here. Or you simply write out every possibility. If I write out every single possibility and then add, well, there's only going to be one that's negative 6, and just read what it says. x minus 2, x minus 4. Does that make sense? Okay. All right, so usually when I get a kid that's like, I'm having trouble with this, it's not that they don't know what to do, it's they're not considering all the possibilities. If you forget that this is positive and that's negative, then write every single possibility. It's 12. That's either 1 and 12, 2 and 6, 3 and 4, and if both of them are negative. If you're really on the ball, since you see that B is negative, you only think about the negative answers, because those are the only ones that you add can get to a negative. I don't care how many times I add 1 and 12, I don't get to a negative anything. The only way I get to a negative is if they're both negative. Which one adds up to negative 13? Negative 1 and negative 12. Like I said, most people, this is a pain to get them together to do this. They're kind of doing this in their head. For the kids that have trouble, I make them do the table to force them to look at all the possibilities. Lots of people, and it's perfectly fine to do this in your head. In fact, a month from now, I can't imagine that many of you wouldn't be doing this in your head. By the way, what's the answer here, Porter? From the table, what's the answer?
-1.
Yeah, but you got to give me the answer in binomial form. Keep talking. Keep talking. I know Porter's got it. Yes? I don't need to necessarily call on everyone, but please be brave if you're not getting this.
I don't.
Shut up. E-learners, you didn't understand that humor there. So I did not literally tell her to shut up. Well, yes, I did. Okay. So this is actually what Sierra's question was. You see this one?
It was confusing.
It's confusing because I flipped everything around, right? Notice I got C first and I got A last. It's the same thing. We got to consider the factors. Hold on. We got to consider the factors of 42. So the factors of 42 are, well, which ones add up to 23? 1 and 42 don't add up to 23.
1 and negative 21.
Negative 1 and negative 21 would add up to that, right? I'm sorry, why did I say negative 1? Negative 2 and negative 21. I messed that up big time. Negative 2 and negative 21 would add up to that. So even though it's written backwards, it's okay. So what's the answer here?
It is x minus 2.
X minus 2, x minus 21. If you want to write it backwards, you can. Right? It looks weird. Me personally, if I was solving this one, step 1 would be, I don't like that order. I'm going to write it in the correct order. X squared minus 23x, and this is positive plus 42. That's how I would handle that one. Questions? Okay.
That's just kind of easy. I
All right,
know my
box
multiplication.
number 6. Box number 6. I'll give you a 30-second head start. How many boxes? That's it. That's the last box. What do you know? How did you have an ink explosion?
So like the thing is, I opened it and then the bottom, I guess, was.
I don't know if that'll work or not.
It does.
I bet you could use some. Take that thing, put some hand sanitizer. I bet that would make it work. Sarah, you feeling confident? Okay. I know Julie's confident because she did problems. Chris? Piper? So, Piper, do you know the technique? Like what you need to do? So I'm going to claim that the issue is you got to come up with those factor pairs. That's the hardest thing, right? But once you find the factor pair that adds up to that, you know what to do beyond that? All right, let's do the first one together, Chris. 6. Give me all the factor pairs of 6.
2 and 6.
2 and
6. Why did I say 6?
I don't know.
3. No,
2.
3. Okay, I'm.
And
Yep, 3. There's 2 and 3. There's 1 and 6.
okay. And remember, if B is negative, then these are going to be negative. So which one adds up to negative 7?
1 and 6.
Therefore, the answer is
X.
just read what that number
I
says.
know, X minus 1,
And x,
x minus 6.
you got it. Piper, yes or no? Let's do the last one, Piper. Okay, give me the factor pairs of 12. Two numbers multiplied. I want you to start with 1. 1 in 1 in 12. 1 times 12 is 12. 2 in,
6.
and is there another number multiplied to get you to 12?
3.
And 3 times what is 12? One of these adds up to 7. Which one? Except that it's minus, so we make both of these minus. So the final answer is, start with x, and you read these numbers. X, parentheses close, open parentheses, x. That's all we're doing. If you can do that, now remember we did 2 flavors. The first one, these were positive. That means all of these will be positive. And the second one, when this one is negative, then all the numbers are negative. Okay? That's all you got to remember. It's a big ask, though, to do this, though.
It's a bit
My
wet.
big,
He said ask.
I'm pretty sure I said if I say the word angle side, it's in geometry. It's not in algebra 1. All right. It's a big ask, right? To do this, if your math fact's weak. So my recommendation, Piper, is to have what in front of your face? And just look at the ones column. 1 and find the 12. Oh, it's 1 times 12. Look at the 2 column, 2 times 6. Look at 3 column, 3 times 4. If you have that in front of your face, this will speed the process up. How many people right now are doing this whole thing in their head?
Me.
Okay, and that's what typically happens.
Me.
And you're going to wonder why we do 3 days of this. We're going to do the 12 new cases. Friday's a practice day. So for those of you that are already running with this, okay, great. I'm happy for you. You still need some practice. All right. That ended right on the right side.
Did it.
It did. Keep the homework.
That's so nice.
There's too many people that gotta go to the locker to get it. All right, Haley, are you here with us? Any questions? Haley is not with us. All right, just so that you can see the learners, here are the 4 answers. And that will do it for today. We did both cases. Catch you tomorrow, e-learners.